All right, we'll just go ahead and get started. How was your week?
It was, I mean, it was about normal, I suppose.
I'll take that. Shoot, I'll take anything above or equal to par. I'm okay with. I'll try to have tonight's meeting go fairly quickly, unless you have a bunch of questions that are plaguing you or anything. It's kind of nice to have the tic-tac-toe stuff out of the way. I know for some people they were a little bit overburdened with it. Not necessarily because of its complexity. It's just got a lot of subparts to it, and those subparts can be, pretty extraordinary as far as what they demand for each particular part. So trying to print it out, how do you print it out in a nice fashion? How do you switch players in the middle of the game, and when do you do that, and stuff like that. So I figured people were going to have a struggle with it, but I got a few people's responses who were just like, I quit programming. I don't want to do this anymore. This is terrible. I'm like, whoa, 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 don't go that far. It's a pointless and pedantic exercise, and it encompasses a lot of parts, which is part of why they wanted it included in the curriculum. So hopefully you didn't find it too daunting yourself.
It was, I mean, it was a good test, but once I started like getting into it, it was, not as insane as I thought it was going to be.
Yeah, I'm
Sorry
glad to
about
hear that.
in the background.
Oh no, that's great. I mean, who knows? Mine might start piping up here in a little bit.
Right.
I'm always, precautious. I'm like, the baby's going to start crying, and then, hey, video's over. I'm sorry. So yeah. Anyway, when it comes down to a lot of the tic-tac-toe stuff, I mean, honestly, like I said, it wasn't. It has a lot of parts to it, which is what makes it seem so daunting. Even thinking about like the main part of the game, anytime that you're making a project in general, making modules is probably the best idea, and it helps you parse it all out, because then you focus on one thing at a time. Like, before you're able to do anything with the game board, you have to initialize it. So I have to like create the proper rows and columns by appending columns onto each row on through it. So I mean, that all makes sense, but then you have to get into how do I print it? So you separate these tasks into these sub-modules, which makes it a lot easier to find out when you have a problem, where was the problem caused? Like, where was the start of it? You can kind of go to that area, clean it up. The real part that I always struggle with personally when it comes to programming is the main, because following how the main is supposed to go, like, okay, so let's start with our initial, usually initialize several variables. So if I'm going to have a loop in there, I'm going to have a check against that loop. So what am I going to do? Put win game, or win game equals to false, or but then you have to think about, when is there going to be a time when the game is not technically won, but it still has to like continue, or I can't just display a win. And you're like, what about a tie? So then you have like 3 criteria for it. So it's game win, game win, game continue, or game tie. And you're like, well, I can't call it game win, because if I end up doing that, that really doesn't help with a tie. So you have to start sifting through this stuff, because if you could figure out that it's a 1 or a 0, it's either true or false. Shoot, use a Boolean, but that gets into the minutia of it, that makes things more complicated and makes some people just want to quit. So just don't do that. That's all I'm saying. Don't quit. Figure out how to do it, and when you hit a dead end, backtrack a little bit and figure out what you can do to fix it. So yeah. Anyway, essentially the main for me was that I had to put continue game and keep it true, initialize the grid, and then do a while loop of the continuation of the game. I'd print the grid every single time. I'd check to see if the game was won. And if it was won, then I would say it was a win. If it was a tie, then it would come out tie. And then I would print based on that stuff. So honestly, I try to keep it as streamlined as possible. And I will post this eventually. I just know that there are some people who I think were so overwhelmed by it that I'm going to give them a little bit more time to complete it. And especially for next week. So I hate to ever give people work during break, because you are aware that next week is fall break, right?
I knew it was fall break, but all of my classes had due dates, so I was confused, because the due dates haven't been updated yet. Mm-hmm. So perfect, because that is awesome.
Good. Yeah, I kind of feel bad, because even some of the ones that I had, I ended up extending it out into next week, because I mean, in this class we've got the typical assignment, and then you end up having you have a quiz, and then you end up having an exam this week. And so I wanted to like not overwhelm people so they can push it back a little bit. My preferred way that they would go is they get the quiz done early, the exercises done early, and then try to get the exam done this weekend and just have a week free. I want you guys free. I want you not to have to worry about anything, but to be honest with you, my entire time of school, work, etc., if there's ever a break, I'm actually filling my break with work. I look at it as like a week to catch up, which is terrible because then I never rest. But when the heck do I ever rest? So I'm sure you guys are in the same boat, but I prefer you try to rest if you're at all able to. So give it a shot. So yeah, anyway, try to complete the exam as early as possible. What I'm going to do right here real quick is I'm going to go over what's on the quiz, because the quiz this week is kind of messy when it comes to polymorphism and inheritance. It's not as straightforward as people would like. People tend to struggle a little bit with object-oriented elements of a language. And just along with that, the next level deep in intensity when it comes to classes and object-oriented is dealing with polymorphism and inheritance, because that's what flows from the classes. So my encouragement is to try to take the quiz, but I'll go ahead and tell you essentially what's going to be covering the quiz. So I hope you're ready. What you're going to want to know for the quiz this week is you're going to want to know what is inheritance. What exactly does that comprise? You're going to want to know what polymorphism is, know some examples of both inheritance and polymorphism. You're going to want to know what is a subclass and what are some other names for a subclass, like a child class, for example, or a derived class, or also too, what is a superclass, and what is that? What are other names that's used to comprise? So that'd be like a parent class, for example. You'll want to know how do you override a method in a superclass. So if you end up having a superclass or a parent class and you have a child class that's deriving from it, you're going to want to know how to override some of the methods that come from the parent class. So how exactly do you do that? You're going to want to know what the root class in Python is. People always want to make the guess. They're like, the root class must be class. And you're like, no, actually the root class is object. So know what the root class in Python is. Know what the function isInstance does and how to use it. Essentially what that does is it checks what if a particular object is an instance of a given class. And that's really helpful when it comes to inheritance and polymorphism, because you'll have a class, an object that you create from a class, and you're not sure if it's actually the child class or the parent class or where it stands in that, because they share similar elements. So you're like, what is this? And so on occasion, you'll want to use isInstance to see if a particular object is a child of, or is an object of a particular class, or whether it's deriving from it. So it's a useful little mechanism, helpful and object-oriented. So you're going to want to know how that's used. You're going to want to know what the different relationships among classes are, and there's several. There's aggregation, there's composite, there's association. Know what these are and know how they're utilized, because it'll actually make you feel quite a bit smarter and actually help you articulate what your class structure is when you're building, applications down the road. Somebody's going to end up asking you, what is a car? And then you're going to say like, well, it is a composition. So it has a composition relationship. It's got wheels. So the wheels are, comprise the car. So you can't have a car without all these pieces that are in composition of it. But, that is because it's a composition relationship. The wheels are the composite pieces of said car. So knowing these actually will help you understand, in talking to other programmers, how exactly things fit together and the relationships between them. If you find yourself in a place that encourages you to use UML diagrams, it'll be super helpful. What else? Know this is actually kind of rough. When a constructor is called in a child class, what is and isn't inherited? So if you're creating a child class, and it's deriving a lot of things out of the constructor and stuff of the parent class, know what isn't taken from the parent class, because that'll end up tripping you up in a lot of these random questions on quizzes and the like. And the big one is know how to call a superclass initialize method, the INIT method. Know how to call the superclass's initialization method. or the constructor from a subclass. There's two ways to do it. You'll find that in the book somewhere. I encourage you guys to go and search that out. But there are two ways that you can end up calling the constructor of the parent class from the child. So know how to do those, and that should put you in a good place for the quiz. Fair enough? There's a lot to throw at you, but hopefully, you know, pause the video, slow it down, see if you can track that all down. Sound good?
Yeah, yeah, absolutely. Any heads up is nice.
Awesome. Well, hopefully I can give you a little bit more heads up when it comes down to the exam. So honestly, the exam, I don't want you to be too freaked out, but what I need you to do for me is a favor here real quick. Are you able to see your past answers on old quizzes that you've taken?
Let me check real quick.
Go ahead. Thank you. Thank you. I don't want to leave anybody high and dry. Because basically speaking, I'm going to give you the heads up of how this has worked. I'm trying not to be an evil professor. I want to try to take care of you guys as well as possible. You guys work hard. You got a lot going on in your lives. And I don't want to make things more dramatic or terrifying for you. So if you give me an answer to that, if you can see those past answers, you can. Good.
Yep.
And I know, well, from what I understand is that you can only see the past answers from past quizzes if you actually took it. So if you missed it, you're out of luck. You can't look at any of the answers because it's barred off from you. So incentive to take the quizzes. So here's what happened. I'm going to give you an overview of the bureaucracy of the school. I love academia. I think the people who work in it are incredibly hard workers. They don't get paid enough or taken care of well enough, but they get the reward of actually taking care of amazing students like you guys and trying to see you learn some amazing things. You know, change the world, make it a better place. But the downside is that on the administrative side, they're not always like incredibly on top of things. This course in particular was created, built up from the state. The state board essentially ends up creating this course, says this is what you should study in it, this is what content needs to be covered. And what they do is they provide the quizzes in some capacity with some alterations that we get to make if we say that some of these test questions are unfair or something. But they give you all these quizzes and all of the exams and all of the homework questions. They say this is actually a good example of what you need the students to know. So what ended up happening was, and I noticed this like a month and a half ago, but the exam for this week, the midterm, had 2 questions on it, just 2 questions. And the thing is that it was demanding that you answer 40 questions. So what it would do, how this would work, is if you decided to take this exam and we didn't check it or change it, what it would do is it would just hand you these 2 questions, back and forth, back and forth. So even though that sounds like it'd be awesome, it'd get real old real fast, and heaven forbid you got one of those suckers wrong, or both of them wrong, heaven forbid, because you'd end up having the entire test essentially shoot you into 0 realm, or 50%. So what they said was, okay, there's 2 parts to the exam. There's the first part, which is dealing with a whole bunch of questions. It's like a typical quiz, and it's 40 or 50 questions. And you have the second part, which is actually, it gives you 2 assignments from the book, 2 exercises essentially. So that's what essentially it gives you. So the recommendation was, hey, we gave you a botched version of the exam. Here's what we want you to do. We want you to just erase part 1 of the exam. And instead of it being worth 100 points now, make it worth 0. Nobody takes it. And then I want you to go to part 2, which are the 2 homework assignments, essentially, the book assignments. And I want you to make that no longer worth 50 points. I want you to make it worth 150 points. So imagine this. You've got 2 book assignments. One of them, pretty freaking difficult. And I've now made these 2 questions worth 150 points. I can just watch you guys lose it as like you bomb one of these test questions. And I'm like, sorry, there goes your grade for the entire semester. So here's what I decided to do. I went through all of the old quizzes. I compiled a list of several of the questions that I felt were fair game that we kind of reviewed and went over. Things that you've been asked before, that you've been given the right answers on. If you got it wrong, even if you got it right, you've kind of seen them. So I've taken a lot of the questions from the quizzes. Oh no, my picture froze up again. I hate it when it does that. Take a lot of, anyway, carrying on. take a lot of the questions from the quizzes, and then I've recombined them all and took 50 of them, and then I replaced them into the exam. So if you get a chance to just review your old quizzes, then the first half of the exam should be a piece of cake for you. Is that fair?
I think that sounds very fair.
That's what I like to hear. I'm glad you didn't want to put up a fight for that, because I was like, really, I don't know what else to end up doing, you poor souls. And I didn't want to see you guys end up hitting the 2 book questions and being like, I don't even know what the heck to do with that, and like watch your world crumble. So here's what's going to happen. Go ahead and study the quiz for exam part 1. And I'm going to go ahead and show you a little bit about what is expected of you for exam part 2. So at least you have some understanding of what you're getting yourself into. So what I'll do is I'll share my screen here real quick. And then I'll try to put this all over so you can take a look. All right. Can you see my screen?
Yeah.
All right, cool. So essentially, let me see if I can actually find the, yep, I'm going to do that. So down here, yeah, that's not what I wanted. Give me the module. So down here, you'll actually see there's exam part 1 right there. And then here's part 2. So we'll kind of bounce into this real quick. And so I tried to give, right here is the test question essentially that it wants you to do. On page 350, exercise 10.7, count single digits. So essentially, and I'm going to try to run you through this because when I read these, I was like, what is it asking me to do? So this is basically the same instructions as what's here in the book, but I tried to give more explanation on it because this might not seem very clear to you. All right, so write a program that generates 1,000 random numbers between 0 and 9 and displays the count for each number. Hint, use a list of 10 integers, say counts, to store the counts for the number. Zeros, ones, all the way through 9s. Does that make very clear sense to you?
Does it mean like if the number is 1.03, then it counts as a 1, or if it's 0.05, then it counts as a 0?
Great question, and that's why I gave more clear directions. So yeah, basically it's interesting because the thing is you shouldn't have any floats. That's essentially what it's getting at. So here's what I decided to do. I gave a little bit more direction on that. So this is exactly the question as it asks. I gave directions instead. So you create a list because this is chapter 10 right here. Chapter 10 was all about lists. So use a list. Create a list of 1,000 randomly generated numbers between 0, inclusive, and 9. So it needs to include 0, it needs to include 9. So that's the idea, is that you're creating a list and you're randomly generating. So you're going to import the random generator, and you're going to generate a number 1,000 times. You're going to keep adding it to the list. Does that make sense so far?
Yeah.
Okay. And then you're going to count the number of times each value is found inside of that list. So what that means is you're going to say, how many zeros are there? And then display, print out how many zeros there are. How many ones are there? This is how many ones there are. How many 9s are there? This is how many 9s there are. Essentially, you want to print it out with a good representation of the number of times each number is found in your list. Does that make sense?
Yeah, I think so.
All right, cool. So that's the thing. That's exactly what you're doing there. I wanted to give more clear directions because otherwise people would look at that, freak out, because it's not very clear. So, and then this one I thought was far worse. My gosh. And I thought I'd give you guys a little bit of a heads up on how exactly to make this work because it's not straightforward. What page was that? 385. All right, so here you go. Gosh, makes me laugh and cringe at the same time. 9 coins are placed in a 3x3 matrix with some face up and some face down. You can represent the state of the coins with the values 0 for heads and 1 for tails. Here are some examples. So essentially, you don't care about having 5 of these. It's only concerned about one little list right here. So this is like one printout of what they're expecting. And then it gives you several examples of it. So each state can be represented using a binary number. For example, the preceding matrices correspond to the numbers. So right here, for example, you have 0, 0, 0. So it's going to be the top line, 0, 0, 0. Then you have 0, 1, 0, And that's 0, 1, 0, and then 0, 0, 0. So essentially what this is that this binary number right here is representative of this particular matrix. Is that good?
Right.
So essentially each one of these corresponds to its appropriate matrix. So there are total, to have a 9-digit binary code right here, there is a total of 512 possibilities. So you can use the decimal numbers 0, 1, 2, 3, all the way up to 511, because 511 would be represented in binary as 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 9 ones, and to represent the states of the matrix. So what you want to do is you want to write a program that prompts the user to enter a number between 0 and 511 and display the corresponding 3x3 matrix with the characters H and T. Here's the sample run right here. So you ask them to enter a number between 0 and 511. They give you 7. And so what do you end up having? You have 0, 0, 0, 0, 0, 0, 1, 1, 1. But you've changed all of those to represent either H for zeros or T for ones. So the user entered 7, which corresponds to that. Since 0 stands for H, 1 stands for T, the output is correct. So this is essentially what you're wanting to have as an output based on this. Does that make sense?
Yes.
So when I first read this, I lost my freaking mind, and I thought that if this was a test question that I had to do, I'd probably start weeping. So I don't want you guys to do that as long as it makes sense to you. Now, do you know how to make numbers into binary? Do you know how to make decimal numbers into binary?
I feel like there was something in the book at some point that said something about it. I don't know off the top of my head.
Right. Okay.
But, was there a part in the book that covered it? It seems like there was.
It is very plausible. I don't remember. I tend to fly through the readings a lot of the times, to be perfectly frank, because a lot of the examples don't help elucidate it beyond the one principle it's trying to display. So what I'm going to do right now is I'm going to show you that there are 2 little methods that you can end up doing to actually end up getting this. I'm going to show you the proper way, which is actually to do it manually, and then I'm going to show you the cheap way. Is that fair? And you can decide to use whichever way you want. That is the privilege of you hanging out with me on this call. Does that sound good?
Sounds perfect.
Awesome. So I'll give you the directions right here to make it a little bit more frank. Here is a manual version of this little bad boy. So essentially, I'm just using this as an example. The number that I'm choosing right here is 511. So I'm giving it the maximum amount. What that should do is it should print out 9 ones. So what I do here is I create binary, which is a string, and it's empty. It's an empty string right now. And while the number is not equal to 0, and what I'm going to do is I'm going to do integer division on number until it's cut down to 0. So eventually we'll just knock this down piece by piece until it's nothing. And how binary is constructed is that you're trying to figure out if something is divisible by 2. So what we're going to do is we're going to take binary, and it's going to start backwards essentially, because that's how you're counting it. So you're going to take binary, which is empty right here, and you're going to add onto this number, and then see if the modulus operator, if it's divisible by 2. So if it's an odd number, it's always going to display what number if it's odd?
1.
There you go. So what it's going to do is it's going to print out 1. So 511, that's odd. So the first number you know is going to wind up being 1. So it's going to append 1 to this, and then it's going to come down here and it's going to divide this out by 2. And it's going to get rid of the remainder essentially, not give a heck about it. So that's going to cut this down by 2. Now it starts it back over again in the while loop, and it's definitely not equal to 0. And so we're going to keep doing that. We're going to see if it's divisible by 2. Is there going to be a remainder left over? If so, then we're going to make it a 1. Otherwise, it's going to be 0. And so this is how it's constructed a binary, essentially. That's how you construct a binary utilizing a manual method. So there's my little cheat for you. If we decide we're going to run this little bad boy real quick and count that out, it looks like there's a grouping of 3, a grouping of 3, and a grouping of 3. So there you go. There's your little printout of the binary of this. So take a nice look at it. Make sure you kind of at least have some familiarity with it. Now let me show you another little cheap way. You ready for this? It's one of my favorite little things. Fun things to know about Python. And I'll just throw a print in here just to give an illustration. So there's a nice little already included method that you can end up putting in here. It's called bin. That stands for binary number, right? And what you want to do is you can just throw your number in here. And what I should do, before I botch this, Let me put it up here. Is that fair? Because now number, we'll just use the same number. All right, so I'll throw that in there. That's all I do. And this is what it gives me. It gives me as a string OB, which is how it prefixes any binary. So that's how you know it's a binary number. It actually gives you that prefix. And then it gives you, look at that, the 9 ones. So avoiding this entire manual discovery of the binary of that particular number in decimal, this is a cheap way to get around it. How do I get rid of the rest of it? Well, you know that. You've done little things with that before. So let's go ahead and just do a string, slice the string down a little bit. So we'll go ahead and try that little bugger. And what it does is it gets rid of the first 2 letters in that particular string. Look at that. Comes out spot nice. So what I love about Python, here we go. Ignore all of this complicated mathematical input, and instead use the functions that are already interlaid. Other fun things that you might want to know in the future, not that this is important to you right now, but hey, since we're already here, why not? You can also short circuit things into hexadecimal if you so desire. OX is always the prefix for hexadecimal. So if you need a hex number, that's how you end up finding it. And I don't know if you know, do you know anything about hexadecimal at all? I don't expect that you would have to.
No, that's for like colors on HTML, right?
Yes, in part, yeah, absolutely. And there are a few other things that function with it as well. You can actually, if you want to, go into some video games and actually change your save files, because sometimes, more often than not, they still use hexadecimal. So it's fun if you ever want to go and change the registry and stuff. You can throw around a bunch of hex, but I wouldn't dare, because hex is a little bit messy. But essentially, F is represented by 4 ones, right? So if you end up doing 4 ones, that's 8 ones, and then another 1 on top of that. So there you go. There's 9 ones encompassed in that nice little number. Cool?
Yep.
That's in a nutshell, man. And so yeah, essentially that's what you want to take a look at right there. That's going to be your best friend for this particular instance. You're taking the binary representation of a decimal, and you're trimming up the first 2 portions of it, and that should take care of you. So the reason why, even at the beginning of our call, I was like, yeah, let's wait a little bit longer. It took me 5 minutes to do your first exam part 2. That's what I was trying to do. I was trying to knock it out right before our conversation. So I took care of that in about 5 minutes. It'll probably take you guys a little bit longer, but really, it's not crazy difficult. It can be pretty straightforward. Don't make it more complicated than it needs to be. You know, when it comes down here, things that I want to see, if it asks for a list, if I ask for a list up here, make it a list. If I ask for a matrix in some way down here, make it a matrix. It's encouraged that you end up utilizing a matrix, but you can even use a list here. A list is still possible if you want to break it down and print it out appropriately. But that's in a nutshell. Cool? Anything else?
No, that was a lot of really useful information, actually.
Awesome.
Info.
Awesome. Well, happy to help on that. Yeah, when it comes down to you guys have been doing, everybody's been doing a lot better when it comes down to homework assignments. I think I scared everybody when I ended up asking last week. I was like, if you really want an extension and yet you're not going to do the work, then don't bother asking me. Nobody's asked me for one much since then. So I'm like, well, I didn't mean to be a jerk, but at the same time, like, I'm glad that people are trying to get it in at appropriate times. But if you guys do, if anybody in the class desperately needs additional time, or they're going through a crisis of worth or something, because it's interesting when it comes to like watching a skill-based profession like professional coding, programming, and the like. One of the things that blows my mind is how quickly people tear down their own intellect. And don't do that, right? Like, don't tear yourself apart because you can't get something right. In fact, if you did that in front of an employer, it'd probably be like, oh my gosh, I don't have time to be your cheerleader. In fact, what you should do instead, what I would love for all of you to do, is if you end up hitting a hurdle and you don't feel like you can cross it and you feel like such a failure, say, I will do better, and I will stand up and figure out how to do this and make it happen, because you can train your brain to do anything. You just give it a little bit more time. And really the key to all of this is time. If you take the time to think about these things and understand the flow of the logic that's behind it, then slowly it will come to you. But I'm not expecting you guys to be professionals overnight. I'm not expecting you to be professionals over the course of a semester. You know, take your time, take it easy on yourselves, and and keep whittling away at it. If you give it time, then it will give much more back to you. I mean, and just to give an illustration of that, I have a certification next week test that I have to do on Friday, and I have read darn near 1,000 pages on stuff. And I'll tell you right now, none of it is in my brain. Like every time I read, it completely exits immediately after I'm done. So the next week, I'm going to be busting my rear end, not to memorize things, but to train my mind to understand it, think of it. And hopefully by next Friday, I can come back to you all with good news that I actually have a masterful certification that will make me massively more productive and do some freaking crazy things with Python, R, Scala, and a bunch of big data stuff. So anyway, keep working at it. And if you feel like you're failing right now, just dedicate time to it and you'll get a lot better. That's all I have to say. And if you need anything, let me know.
Right.
Awesome. Well, that's it for me. That was the fastest call I've ever had.
Yeah, under 40 minutes. That was pretty quick.
Thank you. Thank you. All right. Well, I would bid you good luck and good fortune on all this stuff. And rest up next week, please. Take some time to yourself. Enjoy yourselves.
I will be on a beach in Florida. And
that's what I am talking about.
I'll probably still be doing a little studying, but I will be enjoying the beach as well.
Well, you can just remember me for a second and the hell that I'm going through trying to study.
Hey, I've got my A+ certification 1001 this Friday.
Hey,
so feel your pain.
All right. Hey, solidarity. I'm sorry to hear that, but go and crush it. I have faith in you.
Yeah, I hope so.
All right. Hey, take it easy. We'll talk to you later.
You too. Thanks. Bye.
All right. Bye-bye.